All right, Chapter 8, Section 2, Law of Sines. Watch out. It's a new Precalculus reality cops show, Law of Sines.
Huh.
Just kidding. It's not.
I'm excited about that.
So, for the law of sines, if all your angles are acute, we should use the law of sines. Or if you have two acute and one... Oh, wait, we're just talking triangles here. So we're going to look at triangles. So we're going to look at a scenario where I cannot use right triangle trigonometry because these are not right triangles. It's ridiculous to use. In order to use trigonometry, sine, cosine, tan, you have to have a right triangle. So what do when we do not have a right triangle? Like this, all angles are acute, or you have two acute angles and one obtuse angles. These are called oblique triangles. So in order to solve an oblique triangle, where none of the angles is a right angle, we are going to use the same convention where if I'm calling out angle A, so if the angle is capital, its opposite side is its buddy side. So this is little a. Angle B has side little b, and angle C has side little c. The hardest part is the C's, because when you write a capital C and you write a lowercase c, sometimes you can't tell which one's which. But we always do the capitals for the angles and the lowercase for the sides. Okay, so we're going to have 4 different cases. Case 1, one side and 2 angles are known, angle, side, angle, or side, angle, angle. Now, how many of you, this is the first time we're seeing side, angle, side, angle, since geometry? Oh, remember when you were young and gorgeous in geometry? And now we're all old and crotchety in precalculus. So we're going to look at the 4 different cases because there's different methods for each case. So in case 1, we have 2 angles and an included side. For case 2, we have 2 angles and a not included side. Oh, that's still case 1. Case 2, we have 2 sides and a not included angle. And the reason we know that this is the bizarre scenario is because what is SSA spelled backwards? So that is your mental clue that something's wrong. Side angle side is when you have 2 sides and an included angle. And case number 4 is when we have all of the sides. Okay, so the law of sines is used to solve triangles for case 1 or 2. So the law of sines says the sine of angle A over side A is equal to the sine of B over side B, which is also equal to the sine of C over side C. And thanks to my lesson in geometry yesterday, this is called an extended proportion. So these 3 cases, although this says case 1, we want to use law of sines. So when you get a question that says, which situations do you use law of sines? It's for angle, side, angle, angle, and side, angle. It's going to happen. So we're going to use so you can split up the extended proportion. So if you only have angle A and B, you definitely want to condense the proportion and use sine A over sine B over B. All right, so let's solve it. If we know angle A is 40, angle B is 60, and side A is 4, once again with these, I recommend drawing the picture. I won't even talk to you unless you have a picture down on your paper. We're going to solve the triangle, which means we have to find angle C, side C, and side B. So we can find angle C pretty easily. We know that triangle sum theorem says they all add up to 180. So C has to be 80 degrees. Work smarter, not harder. Don't use law of sines when you can just use the triangle sum. All right, so since we have A and B, we're going to use the property sine A over A equals sine B over B, and sine A over A equals sine C over C. So A is equal to 4, B is 60, C is 80. So if we go sine of 40 over 4 equals sine of 60 over B. And then we can go sine of 40 over 4 is sine of 80 over C. So we're going to, this is two different solvings, so we're going to cross multiply and divide by sine 40. So sine of 60 times 4 equals B, sine of 40 times B. We're going to divide by sine 40, and we get B is 5.39. Then we're going to solve this one. Cross multiply sine 40 times C equals sine 80 times 4. And then divide by sine 40. And we get 6.13. All the sides, all the angles, we are done. All right, so let's look at this triangle. We have 35, 15, we have side C, and we don't have A and B. So we have angle, or side, angle, side. We can find side C, or angle C, using triangle sum. And then we're going to use law of sines. Sine A over A equals sine C over C. Sine of 35 degrees over A equals sine of 130 over 5. Cross multiply and divide by sine of 130. And you get 3.74. So all we have left is B. So we use sine B over B equals sine C over C. Sine of 15 degrees over B equals sine of 130 over 5. Cross multiply, divide by 130 side, and we get 1.69. All the angles, all the sides are accounted for. We have solved this triangle. Okay, side angle triangles are the dumb ones. They're the weird ones. Don't be offended. This is the ambiguous case. So we're going to evaluate. So we threw in, because this is a weird case, and the way I remember it's the weird case is because SSA spelled backwards is a weird word. Sine A, so if we throw in an altitude here, a height of our triangle, we now have a right triangle and we can use trigonometry. So sine of A is equal to H over B. We're going to do a test when we have side-side angle. We're going to do a little test. So we're going to calculate what B sine A is, and if A is less than H or B sine A, so if side A is smaller than the height, then you can't have a triangle because that side isn't long enough. It's like this little dangly arm. It's not long enough to make a triangle and close it up. So if A is smaller than H, which is B times the sine of A, then you are not a triangle. If A is equal to H, then you are a right triangle. And if B sine A, B is, remember this side, is, if H is equal to B sine A, which is less than side A, and A is less than B, two distinct triangles can be formed. So then you have the two triangle scenario. What? And then you have to solve it for one scenario, and then solve it, and you have a scenario. It's crazy, man. If A is greater than or equal to B, only one triangle can be formed, and that's always the situation you want because that's awesome. So let's see how we apply that. If A is equal to 3, B is equal to 2, and A is equal to 40, so we have side, side, angle. We use the law of sines, and we get that there are two angles since B is in between 0 and 180, and because the sine of B is approximately equal to 0.4, so we have to, all right, so we use law of sines to find that we can either have angle B is 21.5, or the second possibility, angle B is 154.6. We do a little test, and we can rule out 154.6 because when we do triangle sum, if this is 154.6 and we already have 40, we're going to get a number that's bigger than 180 without even counting in angle C. So we know that it's a not 154, but we have to test. So when that's the case, we find angle C by going 180 minus 40 minus 25.4. And we get angle C is 14.6. Or sorry, 114.6. And then we use that and law of sines to find side C. So we cross multiply, we divide by sine 40, and we get 4.24. So this triangle is 114.6, 4.24, and 25.4. All right, so this is where you have both solutions. This is the scenario where you're going to have to fuss with two solutions. So I'm given this triangle. There's two possibilities, two possible ways we can draw it. I got 35 in the corner here, I've got 8 here, and my other side is 6. So we go sine 35 times 8 equals sine B times 6, divide by 6, and we get 0.76. Inverse sine on our calculator, we get 49.9. Subtract that from 180, and we get 130.1. So A plus B in both scenarios is less than 180. So we can't discount that second angle. So in the first scenario, when B is 49.9, our third angle is 95.1. And then we solve it through using that first angle. So sine of 35 times C1 is sine of 95.1 times C. And then we divide by 35 degrees, sine of 35 degrees, and we get 10.42. So that's in the second scenario, when our angle B is 130.1, our top angle C is 14.9 degrees, and then we use law of sines to solve that one out. Cross multiply, divide by sine of 35, and we get 2.69. So we have two scenarios, so there's two different triangles we are solving for. The one where we have the obtuse angle here, and the one where we have the obtuse angle here. That's why we just pray that there's no law of sines. Or that when we get side-side angle, this happens. This is my favorite side-side angle situation. So if we have no solution, side A is 2, A is 2, C is 1, and angle C is 50. So we use law of sines. Sine A is equal to 2 sine of 50, which is 1.53. I inverse sine that. And I get I get an error message on my calculator. This is a scenario I pray for. Then I can just go no solution and move on to the next problem. No two scenarios, No testing. It just is. So because there's nothing when sine of A is greater than 1, your calculator will explode, and we can move on to the next scenario.